Hello everyone. So we are going to discuss the paper 3 May-June 2020 series. So in this video we'll discuss the first 4 questions, first, second, third and fourth. So without delay, let's start. Here is the question number 1. Solve the inequality modulus 2x minus 1 greater than 3 times modulus 3x plus 2. In this type of question we'll do the square of both the side and we will get 2x minus 1 whole square. We'll remove the modulus because squaring will make it positive always, is greater than 9 times x plus 3 x plus 2 whole square, which when simplified we'll get 4x square minus 4x. I'm using a minus b whole square identity, and plus 1 greater than x plus 2 whole square is x square plus 4x plus 4. So we'll multiply by 9 and you'll get 9x square plus 9 4s are 36x plus 9 4s are 36. So now we'll transfer everything to the right hand side and we will get it as 9x square minus 4x square plus 36x plus 4x plus 36 minus 1, and now this is less than this, so it will become less than 0. So at the last we got it as 5x square plus 40x plus 35 is less than 0. So first of all, we can see there are 5 everywhere, so we'll divide by 5, or we can write or it is x square less than 8x, sorry, x square plus 8x plus 7 less than 0. And now we are going to find this inequality, the solution for it. Before that we require the two roots of it. If the two roots are this, and in order to get the value, the function which is less than 0, means we require this part, and for this part of the function we have the x values as varies from this point to this. So first of all we require the roots, and for the roots we can factorize it, and we can say it is 7. So 7 into 1 7, and 7 plus 1 is 8, so we can directly write it as x plus 7 into x plus 1 less than 0. So you got root as 7 minus 7 and minus 1. So set of values for x going to be minus more than minus 7 and less than minus 1. So I hope it is clear. That was the solution. Let's do the next question. Here's the question number 2. Find the exact value of integration 0 to 1 2 minus x e raised to the power minus 2x dx. So we can see there are product of two function. We'll take first function as u, another function as v, so that we can use the formula of this as u times integration of v dx minus integration of differentiation of first function and integration of second function and whole integration. So let's do it in this way. So it is going to be is equal to 2 minus x as it is, and integration of e raised to the power minus 2x is e raised to the power minus 2x upon minus 2, that is differentiation of e raised to minus 2x, and we'll put the limit 0 to 1 minus integration of 0 to 1 differentiation of 2 minus x, that is minus 1 only, and again integration of e raised to the power minus 2x is e raised to the power minus 2x upon minus 2 dx. These two got cancelled, and now we'll simplify it more. It is 2 minus 1 e raised to the power minus 2 over minus 2, and then minus the lower limit, that is 0, so it is 2 minus 0 e raised to the power minus 0 over minus 2, and minus times integration of this is going to be, say, minus minus plus, and it will come out, it is 1 by 2, and integration of e raised to the power minus 2x is again e raised to the power minus 2x upon minus 2, and limit from 0 to 1. So we will put the limit here. Now we got it as minus 1 over 2 e raised to the power minus 2 from here, and this minus minus will become plus, and e raised to the power minus 0 or 0, it is 1, and minus, it is minus 1 by 2 minus 2, it is plus 1 by 4, and we'll put the limit, you will get e raised to the power minus 2 minus e raised to the power 0. So this is e raised to the power minus 2, it is 1, so we got it as 1, and 1 by 4 into minus 1, that is minus 1 by 4, and it is minus 1 by 2 e raised to the power minus 2 and plus 1 by 4 e raised to the power minus 2. So at the last we got it as 3 by 4, and this minus 1 by 2 plus 1 by 4 is minus 1 by 4 e raised to the power minus 2. So that is the exact value of it. Why exact? Because we are putting the value of e and we are not solving e raised to the power minus 2. So this is the end of the solution. Let's do the next part. Next question. Here's question number 3a part. Show that the equation ln of 1 plus e raised to the power minus x plus 2x is equal to 0 can be expressed as a quadratic equation in e raised to the power x. So first of all, we'll take ln one side and the rest term to the other side. It will become ln of 1 plus e raised to the power minus x is equal to minus 2x. Now we'll use the property, that is we can say definition of log, because ln is log base e. So log base e y is equal to x means y is equal to e raised to the power x. That is the definition of log. So we'll use this and we'll get 1 plus e raised to the power minus x is equal to e raised to the power minus 2x. So first of all, we'll take this minus as plus, so it will become 1 plus 1 over e raised to the power x is equal to 1 over e raised to the power 2x. Now let's multiply the whole equation by e raised to the power 2x. So we will get it as e raised to the power 2x plus e raised to the power x is equal to 1, or we can write it as e raised to the power x whole square plus e raised to the power x minus 1 is equal to 0, which is quadratic in e raised to the power x. So I hope it is clear. Let's do the b part of it. It is hence solve the equation this. So we got this is equal to e raised to the power 2x plus e raised to the power x minus 1 is equal to 0. So we need to solve this, and we need to give the answer till 3 decimal places. So we'll use the quadratic formula. Before that, we'll put y is equal to e raised to the power x, so that it looks similar as a quadratic in y square plus y minus 1 is equal to 0. So first of all, we'll find the y value, and that is y is equal to, by quadratic formula, it is minus 1 plus minus root 1 minus 4 into 1 is 4 into minus 1 plus 4 over 2 times a, that is 2. So it is minus 1 plus minus root 5 over 2. So we got two roots, so we'll put e power x is equal to one value as minus 1 plus root 5 over 2, another value e raised to the power x is equal to minus 1 minus root 5 over 2. So we can see it is going to be negative. This is negative. Of course, e raised to the power x is not going to be negative ever, because we know that e raised to the power x graph goes like this. So it is never going to be negative. So not possible, we'll write here, not possible. So we only need to solve for this. So what is the value of minus 1 plus root 5 divided by 2? It is 0.61803 and so on. So it is that only, and hence x become ln 0.618. We'll get it from the calculator. Ln of 0.618, that is minus 0.5 4, 8, 1, 2. So 2 will give it, make it as 1 only. So this is the last answer because we require the answer till 3 decimal places. So I hope it is clear. Let's do the fourth part, fourth question. So here question number 4. The equation of the curve, if equation of a curve is given as y is equal to x times tan inverse half x, so we need to find dy over dx. Before that, let me tell you, if y is equal to tan inverse x, then dy over dx is 1 over 1 plus x square. So if we know this, then we can directly use it here. So dy over dx, we are going to use the product rule. So dy over dx is first function as it is, differentiation of second function, that is 1 over 1 plus x square by 4 into the differentiation of x by 2, that is 1 by 2, and plus second function as it is, tan inverse of half x, and differentiation of first one, that is 1. So we got it as x 1 x upon 2 into, that is 4, because you can take common LCM, and then it is 4 plus x square plus tan inverse 1 by 2 x. So we can see this can be cancelled. So dy over dx at the last we can represent it as, so it is 2x over 4 plus x square plus tan inverse of half x. So this is the value of dy over dx. I hope it is clear. So let's do the next part. The tangent to the curve at point where x is equal to 2 meets the y-axis at the point where with the coordinate 0, p. So tangent to the curve. So before we proceed for this next condition, we need to know what is the tangent of the curve at x is equal to 2. So before that, we have a point on x is equal to 2. So if you have x is equal to 2, so we can find at x is equal to 2 what would be the y value. X is equal to 2, y is equal to 2 times tan inverse 1 by 2 times 2. So 1 by 2 times 2, and we know it is tan inverse 1, and tan inverse 1 is pi by 4. So y is equal to, you got y is equal to pi by 2. So a point on a curve where you are finding the tangent is 2 comma pi by 2. Now we need to find the gradient, so that we can use the formula y minus y1 is equal to m times x minus x1. So before that we require the tangent, that is gradient m, and gradient is dy over dx at x is equal to 2, and this is we know it was from the previous, it was 2x, so 2 times 2 upon 4 plus x squared, so 2 square plus tan inverse of 2 upon 2. So the value is, it is 4 upon 8, 4 upon 8 is 1 upon 2 plus tan inverse 1 is pi by 4. So now m become pi by 2, 1 by 2 plus pi by 4, and point on the line or on the curve or on a tangent is 2 comma pi by 2. So equation of tangent we can write from here. Equation of tangent at x is equal to 2 will be y minus y1, that is pi by 2, is equal to m times, it is 1 by 2 plus pi by 4 times x minus x1, that is 2. So we'll simplify it. It is y minus y pi by 2 is equal to, I'm multiplying it here, so it is half x plus pi over 4 x minus 1 by 2 into 2, it is 1, and pi by 4 into 2, it is minus pi by 2. So we can see these two got cancelled, and we got y is equal to half x plus pi by 4x minus 1. So this is the equation of tangent to the curve at x is equal to 2. Now we can say from here, we'll write here, so now this tangent passing through the or y-intercept of this tangent is 0 comma 5 0 comma p. So at 0 comma p, because this tangent is passing through this point, so p will be 1 by 2 times 0 plus pi by 4 times 0 minus 1. So we got p is equal to minus 1. I have included so many terms which were not required. We could done it in single line. So I hope it is clear. So we'll proceed for the next question in the next video. Thank you so much for the time being.